All right. Now, what I want to start off today is that if you could take out the packet from yesterday, I want to go over some questions with you on the worksheet. So at the beginning of class yesterday, we were talking about these values. And by the way, unit circle quiz is tomorrow. So make sure you do the practices, the practice on the Schoology. It's very similar to what you will see tomorrow. 25 questions, okay, 15 minutes. So what I would strongly recommend you to do is to know all those values without actually drawing a unit circle. I would challenge you to do that. Because if you, now, I mean, is it a problem? Is it a problem if you have to draw a unit circle and then tell the values? The problem is not very immediate, but if you plan on going to calculus, then you really should not do that. Okay, so please try to think about those values, recall those values without drawing a unit circle. And again, don't forget about the A, S, T, C, the quadrants. Which quadrants are positive? A, it's all functions are positive in quadrant 1. Sine and cosecant will be positive in quadrant 2. Tangent and cotangent will be positive for quadrant 3, and cosine and secant will be positive in quadrant 4. Okay, we make a couple of sketches on sine x and cosine x, which we did use yesterday. We look at the graphs for tangent and cotangent. We will do a few more today. One thing that is, well, a couple of things that are quite significantly different compared tangent graphs, cotangent graphs to sine and cosine graphs is that first, the period, it's not pi, it's not 2 pi, but it's pi. Okay, for tangent and cotangent, the periods, for the parent function, the periods are pi. Thank you. And then when you try to find out the period for other transformed function, that would be pi over b. Okay, if you did I write it down somewhere? I didn't. Maybe you should write it down. So pi over b is for the period, only for tangent and cotangent. Okay, only for tangent and cotangent. So that's the first significant thing that we see here. The second significant thing that's different from sine and cosine graphs would be the appearance of vertical asymptotes. And we need to ask, why do we have vertical asymptotes? Well, because we're dividing it by 0. So that's why we have undefined values. So we see the vertical asymptotes. And also use the tangent graph right here to explain the appearance, the appearance of the cotangent graph. The zeros for the tangent graphs, like these guys right here, would become the asymptotes, because when you do the reciprocal, the 0 become the denominator. So you have a undefined value. So therefore you have the asymptotes for the graph, and the original asymptotes for the tangent graph. Okay, the original asymptotes on the tangent graph would be the 0 or the midline. So you can also consider this a midline right here for the parent function, okay, of y equal to 0 for the tangent and cotangent. So the midline values become the asymptotes right here would be the midline value here. Okay, so we did, and then we have the secant and cosecant graph. So what I asked you to do yesterday was that if you see secant, you go ahead, graph a cosine graph. If you see a cosecant graph, you would go ahead and graph a sine graph. And please do so very lightly so that only you can see it. And then based on the sine graph or cosine graph, you would construct your asymptotes. And because it is a reciprocal function, 1 over a small value become a gigantic number. The periods for secant and cosecant would be the same as the sine and cosine, 2 pi. Okay, so now let's go ahead and do a few more problems. So let's go ahead and do question 2 on the worksheet. Okay, question 2 on the worksheet. So let's look at a few things. We can tell the period. What's the period in this case? Pi over 2, because the b value is 2. Okay, that's a b value. B is 2, so pi over 2. Phase shift, none. Vertical shift, also none. Okay, so now I am going to draw my tangent 2x graph now, and this has to be done pretty skillfully because you don't want to confuse yourself too much. Now, first, I am going to plot my first point. Okay, that's the point on the at the origin. That's the tangent graph. Now, I also know that's the period, it's pi over 2. So that means after pi over 2, I should see the same point appearing again. Okay. Okay, again, do it very lightly. Okay, that's the tangent graph. Do it very lightly. Now, in between these points, for tangent, we'll see the asymptotes, but we'll kind of leave the asymptotes out for the moment, because if we draw the asymptote, it'll be very tedious. Okay, so now, so we know there'll be asymptotes in between those points. Let's take care of the 1 and -1. So 1 and -1 will be right here. Okay, so 1 and -1 would be right here. So you may go ahead and wait, hold on, I made a mess. 1 and -1, 1 and -1. Okay, so make a few points right here. Now let me highlight these points out to you so that you can see it better. Okay, see these points. Now, to minimize the amount of confusion, I'm going to ask you to do this. So these are the points for tangent. So when tangent is 0, what happens to the cotangent? Cotangent is 1 over tangent. So when tangent is 0, so cotangent becomes undefined. And that means for all the points right here sitting at the midline for tangent, they would be the asymptotes. Okay, so let me get those points back to gray first. So they become the asymptotes. Okay. And when tangent was supposed to be the asymptote, now it becomes the actual point on the midline. So that's why I didn't want to spend time drawing those asymptotes, because it could get really, really messy for the tangent graph if we have to include the asymptotes. So, so for tangent,
Why do you for like the plots or for the points that are like plotted at like y=1, why are they plotted like
well, now, well, the period, it's pi over 2. Okay, so it's like you have a horizontal compression. So it's supposed to be pi, right? The period is supposed to be pi. So things will be on the grid at the intersection, but now it's being squeezed horizontally by 1/2 or by a factor of 2. So that's why it's not right at the intersection. So these are the points, okay? 1/1 is still 1. 1/-1 is still -1. So the points, the major points, like the 1 and -1s for the tangent graph, would be used for the cotangent graph as well. Okay, so what I'm asking to make sure that you show in order to get full credit is that make sure you make the dot very visible. If you don't make these dots very visible, then you're putting me at a very difficult position to help you out. Okay, so, all right, so just do a few and then you get the idea. We're not gonna waste time to just putting the dots like this. Okay. So based on tangent, you draw the cotangent. Okay. Or you can also kind of come up with some shortcuts. You may say, oh, when tangent is at the midline, it becomes the vertical asymptote of the cotangent graph. The vertical asymptotes on the tangent graph would become the zeros, the midline. Okay. Right now, what's the domain? Well, what's the vertical asymptote? Or where are the vertical asymptotes? We have so many. So we say x is equal to, well, our first asymptote, it's at x equal to 0, which is very nice. But then how often it repeats itself? How often these vertical asymptotes are repeating itself? Every pi over 2, right? So now this is the way you want to kind of train yourself to think about the translation. So when we say every pi over 2, so every pi over 2, so that every is like the k. Every pi over 2. So we say, oh, so we start at 0. So you can imagine there's a 0 right here, but we don't write it, 0 plus, and then every pi over 2. So k pi over 2. Okay, so yesterday we were talking about we're being lazy. There's so many there's so many vertical asymptotes right there, and it is impossible to list them all out. So how can we come up with a way to write it, express it, so that we can be very simple and neat? We can express the vertical asymptotes location in a neat way. So k would be a good way to represent the integers. K would be all integers, and that's how we say every pi over 2. So k times pi over 2. The domain is x cannot be k pi over 2, because those are the locations for the vertical asymptotes. And the range will be -. infinity to infinity. Okay. Questions? Okay, so just a little quick reminder. So when we use the when we try to describe vertical asymptote, so you may see k pi. Later on today, we may see 2k pi. So just ask yourself, look at the picture, how often it's appearing, every what unit, and the every, it's basically what the k represents. All right, let's go to question number 3. Okay, so you see secant. What should we be thinking? Cosine. So on the side, you can go ahead and write down cosine of x minus pi over 4. So this is what we will graph. Okay. So there's a phase shift to the right, pi over 4. What's the period? To 2 pi, because the b is equal to 1. Okay, there's no vertical shift. All right, so let's go ahead. Okay, take a moment, make your cosine graph. Okay, put the dots on the map. All right, so cosine starts where? 0, 1, but then it moves to the right, pi over 4. And then the period is 2 pi, so that means it comes back right here after 2 pi units, or in this case, 8 squares. And again, using the idea of symmetry. So if it starts at the highest point, so right in the middle, it should be at the lowest point. And then you can fill out the dots. Okay, so you can fill out the dots. Okay. Now, I'm going to show you 2 things right here. Now, once you have all the dots drawn, what you may do is to, well, draw the line. Oops, sorry. If you need to see it more visually, then you can draw the line. And then you create your secant graph. Now, if you want to be more mature, more proficient, then what you can do is this. What you can do is that you understand where when cosine hits the midline, what happens to secant? Undefined. So you may now go ahead and draw your asymptotes. Okay. And if you're familiar with the graphs, you also saw what we did yesterday, that they always, the secant graph and cosine graph, they always share the highest point. And then they go up or they go down. Okay, if it's above the midline, they will go up. If it's below the midline, they go down. So if you want to keep yourself, you want to keep the graph clean, then you can imagine that line being drawn. And then just know the features, right? Just know that, oh yeah, when the cosine graph hits the midline, then that's where you have the asymptotes. Okay. But as a beginner, I always say, all right, let's go ahead and make the cosine graph first. Step by step. And then once you can build your image, then you may skip that cosine line drawing process and then go straight to secant graph. Okay. All right. Now, let's go ahead and try out number 4. Number 4. Yeah, number 4. Well, actually, no, not number 4. Number 6. Number 6. We'll do something like number 4 in a moment. Number 6. Okay, now this one, it's a bit complicated. Okay, so what's the period? Pi. Because b is equal to 2. Okay, so we have a vertical shift down 1. And this is a secant. That means we are thinking about cosine. So you can go ahead, write down cosine of 3 times cosine of 2x minus 1. So based on this cosine function, go ahead, sketch your points. So if you go ahead and make the cosine graph, it should start at the highest point, which is at 3, but then it moved down by 1 unit. So it's going to be here. And then the period, it's pi. So after pi units, it will repeat itself. So I like graphs without any kind of phase shift. That makes my life a lot easier. That makes your life a lot easier as well. So we got these points, the highest points. And then we also use the symmetry. We have the midline at y equals to -1. So so in between those two highest points, you would get the lowest point. So just try your very best to plot it at the edge of the paper. Just make your best attempt. Okay. And now, as you practice more, I would strongly encourage you to find ways to shorten the whole graphing process. So I'm going to say that I'm going to graph at the midline right here. And this is a step you may skip. Okay, because you know it's a midline, then you also know that it will become the vertical asymptotes in a short moment. Okay, so and to avoid a lot of confusing lines, I'm just going to stop the cosine points plotting at this moment, and then I would begin my secant graph plotting. So every 2 squares, you will see a vertical asymptote. Okay. And then based on the behavior of the secant graph, okay, so if you cannot draw the very bottom part, that's fine. Just focus on the upper part. Okay, so if we have enough space to do the bottom part, that would be the case. Okay. So give you a moment to finish your final touch of the graph. So there's no phase shift. How can we describe the vertical asymptote domain and range? Okay, give you a moment to fill out those blanks as well. Try it out. Okay, so what would you write for the vertical asymptotes? We'll write down x equals to, we will say k power over 2, but then we will start from where? We will start at the first one. Now you may write down power over 4, or you may write down negative power over 4. It's up to you. I would choose to write down power over 4 because I can be a little bit lazier not to write the negative sign. Okay, so technically you may pick any point right here where you see the vertical asymptotes, and then you say, oh yeah, it's going to repeat itself every pi over 2 units for the vertical asymptote. So you say k pi over 2. And if you get your vertical asymptotes correctly, then you will also get your domain correctly. Okay, so x equals 2 pi over 4 plus k pi over 2. Yes?
Wait, why is it not just k pi over 4?
Because how often does it repeat itself? Well, 2 squares, right? So what's the width of 2 squares? This is 0. 2 squares is a distance of pi over 2. So you're saying, oh, the vertical asymptotes will repeat itself every pi over 2 units. Okay, so that's what k pi over 2 means. All right, so what about the range? How would you write down the range? From negative infinity to negative 4. Bracket, and then union from 2 to positive infinity. Okay. So you have this weekend to practice all these things. You have tonight, tomorrow night, this weekend to practice all these graphing. So make sure you really seize the opportunity to make sure that you're familiar. Try to make your graphing process as efficient as possible. All right, now we're going to do a couple graphs for this one. Okay, so we are going to go ahead and look at the second one. Okay, go ahead and look at the second one on the first page. So what do? Cosecant of 1/2 x plus 1. What information can we tell already? It's what? Okay, so you can think about that as a sine graph. Okay, so we will plot some points based on the sine graph. What else can we tell? Easily. Vertical shift up 1 unit. And what else can we tell? Period's 4 pi. Very good. Phase shift is none. So these are all quick informations that you can just extract them at a quick glance. So now, go ahead, make your dots. Okay, if you 1 minute to make your dots, and then if you can go even further to draw your cosecant graph, I would strongly encourage you to try it. I love this graph because it has a large period. That means I don't have to put that many dots. Sine graph. All right, so you should have at least these 5 dots plotted out. 1, 2, 3, 4, 5. Okay. So every 4 squares, you will see a major point. Okay. So again, you may graph it out and do this, or if you are, I want you to push yourself and say, all right, if it hits the midline, if the sine function hits the midline, that means what for the cosecant? That's a vertical asymptote because that gives you the zero. That gives you the zero for the denominator. And that gives you the undefined value. Okay. And then again, they would share the highest points and the lowest points. So I love this graph a lot because like bigger period, fewer things to draw. All right, so go ahead, write down the domain and the asymptotes and the range. Okay, try it out. So the asymptote, well, the vertical asymptotes are repeating itself every 2 pi, right? So the way we would write it down, it's x equals 2. That's good. But will be better if we write it down as 2k pi. Okay. So the number sits in the front, so 2k pi. All right. The first vertical asymptote, it's at x equal to 0, so that's why we don't write anything in front of 2k pi. So we simply say, hey, it starts from 0 and it repeats itself every 2 pi. So 2k pi it is. And if you got the if you had the vertical asymptotes correctly, then you will get the domain correctly as well. So domain, it's everything but these values. The range, it's from negative infinity all the way to 0, union, and then 2 to infinity. Right now, so that's something we have done, and let's look at something new. And not only something new, something wrong. Now I need you to make some corrections here for me. See right here, we see some theta. Go ahead, write down x. Okay, and see if you can overwrite this theta. Now the reason why I would fix it is because there is no theta at all in the function. So it would not be a correct thing to say. We have x in the function. So so let's replace all the theta with x. Okay. So do you still remember what the negative sign right here, what it means from first semester? It is, you can write this down if you forgot. It means from the left. Okay. So what we're saying is, hey guys, x is going to 2 pi from the left. X is going to 2 pi from the left. What is the function value? So we say, all right, let's look at the graph. Okay, you can go ahead and use your finger to trace the graph. So we are going from the left to approach 2 pi. Where's it going to? Positive infinity. And for the other one, we would say, hey, if x goes to 2 pi, the positive sign means from the right. Okay, so from the right. And by the way, you will see this symbol quite often next year in calculus. So we will go to 2 pi from the right. So we trace the graph. Oops, nope. We trace the graph going to 2 pi from the right. Okay, from the right, we are heading to negative infinity. Okay. negative infinity. All right, so let's go ahead and see if any question regarding to asymptotes, any questions regarding to the way we draw it. Yes. Well, if it's from the left. So going to 2 pi from the left. Okay, now, can you go all the way from here? Well, sure, but you still go all the way to 2 pi from the left. Okay.
Wait, so how are you supposed to read it? Like, start at pi over.
No. We are like, don't make it too complicated. This one means x approaching to or going to 2 pi from the left. So going to 2 pi from the left. That's it. Okay, don't make it more complicated than it is. It's very factual. All right, now let's look at the next one. Ooh, it's kind of complicated. Got a lot of stuff right here. All right, anything we can tell right away? The amplitudes too, very good. The amplitude, well, for tangent graph, that's not really the amplitude. It's more like a, like we used to plot 1 and -1, and now it's 2 and -2. So so that's like the amplitude, but not really the amplitude. What else can we tell here? Vertical shift down 1. Yes, that's very good. Any phase shift? Left pi over 8. It's a good try, but no. Yeah, so now I really want to make sure that when you look at this, that little 1/2 sitting in front of x, it's going to bother you. Okay, you should feel agitated, like, ugh, do not like this. So go ahead, rewrite this. So 2 times cotangent, and then factor out the 1/2, because you do not want a coefficient of a number other than 1, because that's going to influence the way you interpret your phase shift, your horizontal transformation.
Pi over 4.
So 1/2 and then x plus pi over 4. How can you confirm yourself that this is correct? Yeah, put the 1/2 back in, like multiply back in, check if it's the same. And that's why since the beginning of the school year, I said equal sign is so important. And now that we have the b value of 1/2, well, what's the period? It's a cotangent, by the way. So it's pi over b. So this period is 2 pi. Pi over 1/2. Okay, so it's 2 pi. So what do we do? Now, for our original tangent graph, it starts at the origin, but now let's go ahead and look at the transformation. It's gonna move to the left pi over 4 and down 1. Okay. And what's the period? It's 2 pi. So that means, oh, sorry, hold on. I should move it down 1 more square. All right, so I'm going to repeat myself here. Yes. To the left by what?
The 2 pi, like you have to move that dot over 1 square.
Oh, right. Thank you. Yes, okay, thank you. So still 8. So how many squares? 1, 2, 3, 4, 5, 6, 7, 8. Yeah, 8 squares. Okay. So got these dots. Okay. Now, for the tangent graph that I'm trying to draw, I'm not going to draw the asymptote. So I'm going to just put a few dots here to annotate that we are supposed to see asymptotes here for the tangent graph. Okay. So that means, oh no, hold on, my bad. Yeah, went over again. So we should see some, for the original tangent graph, that should be an asymptote right here. Okay. We should see the nice values at 1 units up and 1 units down, but because of the 2, we have to go 2 units up and 2 units down. Okay. So 2 units down, 2 units up, and then sketching. So what I'm trying to do is to not make a mess for the graphing area. So as long as I can see where the asymptote for the tangent graph, I'm happy. And now let's sketch our cotangent graph. So what I know is that whenever there's a vertical asymptote, the cotangent graph would have a point on the midline. And whenever there is a point on the midline for the tangent graph, it becomes the asymptote. So and they share those special points because you have the reciprocal. Okay. All right, so we'll continue here from here tomorrow. Okay. Again, what's tomorrow? Unit circle quiz. Okay, make sure to do the Schoology practice.